Next up, it's time to set up our own free backend using a service and library called Supabase. So this is where we're going to discuss all the data that we need for our application, create tables within the Supabase database, load that data into our app using an API, and even briefly model the relationship between different tables. And all this will empower you to build complete full-stack apps on your own, which is pretty awesome, right? So that's why I'm so excited to share this technology with you right now. Let's start by quickly getting to know Supabase a bit. So Supabase is a service that allows developers to easily and quickly create a backend with a complete Postgres database. But to us developers, it doesn't even matter what kind of database it is, because we will only interface with it through an API. So this is the really nice part of Supabase, because Supabase will automatically create a database and a matching API, so that we can very easily request and receive data from the server, so where the Postgres database is actually hosted. So it's really all extremely simple. So instead of having to go through the complicated process of building a whole backend and setting up a database ourselves, we simply let Supabase take care of all this. So it's all included and automatic, no backend development needed, which is perfect for front-end developers who just want to quickly get up and running with a new project. And if this sounds great, it gets even better, because Supabase is actually more than just an API. It's actually a complete solution that also includes user authentication and file storage. And again, all accessible from an API or from their own JavaScript library. So with this, you can essentially build full stack applications without knowing anything about backend development. Now, if this sounds like I'm reading an ad here, I guarantee you that I'm not. So I never spoke to the guys at Supabase. I just really love this product because it's so easy to use. And I'm not the only one. So Supabase is growing super fast. So you're gonna be in good company. All right, so with this out of the way, let's now start building the backend for the Wild Oasis management app. So now that we know about Supabase, let's set up a new account and then create our very first database. So let's open up supabase.com, and then here you see that their headline is built in a weekend, scale to millions. So basically what this means is that you can very easily get up and running, but scale this basically to infinite. So to whatever number of users that you need to maintain. They also tell us that Supabase is an alternative to Firebase, which is a similar Google product. However, I really like Supabase a lot more. So it's a lot easier to use and also to interact with using the API. Now, before we create our new account, let's just come here to the pricing page where we can see that we can create up to 2 projects completely for free. You just get these lower limits here in terms of bandwidth and so, but that's of course no problem if you're just getting started. The only small limitation is that if you stop using your project for 1 week, then they will pause your project. But even that is no problem because you can just easily reactivate the project and all the data will still be there. So that just takes a minute and then you are back and up and running. So with that being said, let's start our very first project basically by signing up for a new free Supabase account. So if you have a GitHub account, then I suggest you just use that here, or you can click here to sign up for a new account here. So please do that, and I meet you back here once you are signed up. So this is what the Supabase dashboard looks like, at least at the time of recording. So if you're watching this in the far future, then probably this now looks pretty different. Also, while you were signing up, Supabase probably asked you to create a new organization. So if you didn't do that yet, then please go ahead and do this. So mine, for example, is just called here Jonas Schmedmann's organization. So you can just create your own. And then once you're done, we can finally click here on this button to create a new project in this organization. And again, if your Supabase looks a bit different, then just try to find that button somewhere. All right. So let's then create the project name. So that's going to be the Wild Oasis. And then here you need a password for your database. So I would advise you to just generate this here automatically. And then once you have that, make sure that it is very secure. So when this bar is green, and then please copy this and paste it somewhere secure. So not anywhere in your code base, but really completely outside of VS Code. And we will actually not need this password to build our application, but it's still a good idea to store this somewhere safe. Then next, you can just choose the region that's closest to where all your users will be. So in case you don't know, just use the one that's closest to you. So for me, that's probably this one. And then, of course, for now, you will want to select the free plan. And so then this will start creating your new project and also your new database. And here we are. So it's setting up our project now, but we already have this URL. And yeah, we have links to the JavaScript client documentation, and we can also already start exploring this a little bit here. So one of the most important parts is going to be the table editor, which, well, actually it doesn't work while the project is setting up. So let's just wait for it. Great. So now it's finished. And so let's explore this a little bit. So one of the most important parts is going to be the table editor, which is where we create new tables and can add new data. We also have here the authentication part. We have storage, where we can upload some files, such as PDFs or images. We have here also the API docs, which is going to be really handy, as you will see. And then we can also configure some project settings. But most of the time, we will actually spend right here in the table editor. So creating new tables and maybe even add some data to them. Now, what tables do we actually need to create here? Well, let's find out in the next video, where we are going to discuss how we should model our application state. So, in order to figure out which tables we should actually create inside Supabase, so in our database, we first need to think about our application state. Now, in a big application like this, modeling state becomes a bit different, because we think more about state categories or state slices on a much higher level. So we're not going to plan state at the component level, but really on the page and on the application feature level. So let's bring back our feature categories here, and then from here we can basically figure out what state we are going to need in order to power all these features. So in order to actually be able to build out those features. So for the bookings feature, we are probably going to need some booking state. And the same for the cabins. And also the same for the guests. So all of these are really different features. And so each of them will need to have their own state in order to manage all this data. Next up, we have the dashboard and the check-in and check-out features, which can both be powered also by the bookings state. So the dashboard will simply display a few statistics about recent bookings, and the check-in feature is basically all about updating the booking of a certain user from checked out to checked in, or also the other way around for checkout. So again, these two, all they are going to need is just the booking state or the bookings data. Next up, we have the application settings, which will require its own state slice. And finally, for authentication, we are going to need some users. And so these will again be stored inside their own remote state. So as I was just saying, all of this state, so these 5 states or state slices are going to be global remote state, and they will be stored within Supabase and managed on the front end using React Query. And so basically for each of these state slices, there will be one table in our Supabase database. So from now on, let's actually no longer call this state slices, but really call them data tables, which is more in line with database design. Now, okay, so with this, we now know exactly which tables we need to create, but there is one very special table here, which is the bookings table. And so let's take a closer look at how we are going to model that data. So if we think about this, a booking is essentially a guest renting a cabin, right? So a booking needs information about what guest is booking which cabin. Or in other words, creating a new booking is all about connecting a cabin with a guest. And therefore, we somehow will need to connect all of these tables. Now, in technical terms, behind the scenes, Supabase uses a Postgres database, which is a relational database powered by SQL. Therefore, in order to join these tables, we use something called foreign keys. Now, you don't need to know anything about SQL or about these terms. I'm just quickly explaining how we can model this data and how we should connect these tables. But the technical terms really don't matter. So, as we were just saying earlier, each booking basically needs to know which guest is actually doing the booking. And so therefore, what we're going to do is to take the guest's ID and store that inside a new field inside the booking called guest ID. And the same thing with the cabin. So the booking needs to know which cabin was actually booked. And so, again, we will store the cabin's ID inside a special field of the booking called cabin ID. And so these two, so guest ID and cabin ID, are the foreign keys inside the booking. Now, okay, and so let's just quickly recap this. So essentially, we connect a booking with a cabin simply by storing the cabin's ID, which is the primary key of the cabin, inside the booking's cabin ID, which is then the foreign key. And we also do the exact same thing with the guest. So hopefully that made sense, but if it's still a bit confusing, then that's no problem at all. It will make more sense once we actually implement this inside Supabase. So next up, let's create all the more simple tables, and then after that, we will create the booking table and then do these connections that we just talked about. So let's now implement the cabins, guests, and settings tables based on the project requirements that we saw earlier. So if you want, you can have those open at the same time to better understand the reason behind each of the table fields that we are going to create in each table. And let's start with the cabins table. So let's just call it cabins. The description is not necessary. And here we want to enable something called row level security. And more about what that is, a bit later. And then down here, we need to specify exactly all the columns that we want our table to have. Or in other words, the fields that each piece of data, so each row in our table, should have. So by default, each row in the table will have an ID and this created at timestamp. So let's leave those two. So the timestamp we could also delete, but it's always a very good idea to be able to know when each row in the table was created. But in here, let's create our own fields, so our own columns. So the first one is going to be the name, and then here we need to specify the data type. So these are coming from Postgres, but they are pretty intuitive. So the name is just a string, and we don't want it to have any default value. And let me just make this a bit bigger, just to make sure that you can actually see what I'm doing here. So next up, let's define the max capacity. And so in this column, we will basically be able to say how many people can rent a certain cabin. So this one is certainly a number. So let's do this integer here, and also, of course, no default value. Then we have the regular price, like this, or we could also use the underscore notation like this, which is actually a bit more common in the database world. But since we are going to use these as variables inside JavaScript later, I prefer to use this notation that we are also used to inside JavaScript. So also an integer, and then let's also have a discount. And these again are all coming from our list of requirements. So from there, we can understand that this is the data that we need to represent a cabin. Next up, let's also have a description, which is going to be just text. And finally, an image. Now here the image will actually also be text, because what we're going to store in here is just the URL to the image that we are going to upload to a storage bucket. So remember how I mentioned that we have also buckets here in Supabase where we can upload images to. And so we will in our application actually be able to upload images and then store the URL to each of them right here in the cabin. And this is actually it. So let's save this. This will now create the new table, which takes a little bit of time. And there we are. So the table is of course empty, as we can see down here. So 0 records. And so let's just insert a row here. So just some dummy cabin for now. So let's call this one 001. And we didn't read this anywhere. So this is not in our requirements, but actually the names of the cabins will just be numbered. So 001 all the way to 008. Let's say this is a really small one, just for the max of 2 people, and it costs 250. So maybe euros or dollars. And right now there is a discount going on. So of 50. And then let's say small luxury cabin in the woods. Then here an image we don't have yet. And so let's just save this. And with this, we have our very first cabin in the table. And so let's keep going and create another one. So another table. So next up, it is time for our guests table. So again, enabling the row level security. And then let's start to add the data that we need. So first, the full name, which is going to be text. So most of the time we do actually just have text and numbers here. Then we also need their email address, which makes a lot of sense when we are storing any kind of customer information. Let's also add their nationality, which is always nice to know in a hotel. So, for example, to know how to greet the guests. And then let's also here include a country flag. So this one is also not in the list of requirements, but we will want to have a flag for each country right in our application. And so I'm storing that there. Then also to identify the guest, let's create another field for their national ID number. So national ID number, and again, that's going to be text. So some countries use a number and some use some letters, and so it needs to be text. Here we can then rearrange this, so I think it makes a bit more sense to be there. All right, so this is enough to represent a guest. So let's wait for it here. And so let's insert a row. So the ID and this one here are basically created automatically. And then let's just add one for myself. So here I will just use a test email.com. Then this one also doesn't really matter. Nationality, I am German. And here maybe some emoji, but for now let's just leave it empty. So we're just doing this so we have some data to start with. And so now let's create our final table for now, which is going to be for settings. So here we will be able to define 4 settings, which is the minimum booking length. So this is a number. And all of these are actually coming directly from the list of requirements. So max booking length, again, an integer. Then the max number of guests per booking, again, 2. And finally, the breakfast price. And again, a number. And here maybe let's not use an integer, but a float. So for example, the breakfast might be $9.99. And so then that's not an integer. All right, so let's save this again. And this is actually a bit of a special kind of table for us, because here we will really only have one row, because there do not need to be multiple settings, all with a different minimum booking length. For example, we just want to set each of them here once, and we want them to be able to live here in our database. And so we just created this table, but as I just said, it will only have exactly this one row. So here, let's say that the minimum length needs to be 3 nights. At most, maybe the guests can stay for 90 days, and at most it can be 8 people. And the breakfast costs 15. So let's save that. And with this, we have our 3 first tables created. And so next up, let's then create the more complicated table, which are going to be the bookings. All right, so with those tables in place, now let's create the booking table and set up the relationships that we talked about earlier. So, new table called bookings. And then here, let's start with the start date. And this one should be a timestamp. So this is going to be a date. And so here in Postgres, those are called timestamp. So we have a start date and an end date as well. So when the guest leaves. So again, a timestamp. Then we also want the number of nights, which in our application will be automatically calculated. But it's still a good idea to store that here as an integer. Then the number of guests also an integer, and then let's store the prices. So there will be a cabin price, so the price that the guest pays for just the cabin. So let's make this a float, and then there will also be some extras price. So for example, for breakfast and for other stuff that maybe the hotel might want to add later. And then finally, there is a total price, which is the sum of the other two. So then, of course, it also needs to be a float. Then here we have the status, which will contain basically the status of the booking. So whether it is currently checked in, if it is checked out, or maybe the guest hasn't even arrived yet. So then we will call it unconfirmed. So let's make this text. And this really here is the longest one. So we still need some more. One of them is whether the user has bought breakfast for this booking. So has breakfast, and here we can use the Boolean. So just a true or false. Then we also want to store whether the user has already paid this or not, because there might be the possibility of the guest only paying at the hotel, so only once they arrive. And finally, we just want to store some observations about the booking as well. So maybe they want to let the hotel know when they arrive or something like that. Okay, so these are all the fields that we need for now, so the basic fields. But now it is time to actually connect this table with the guests and with the cabins table, or in other words, to establish relationships between these. So as we learned 2 lectures ago, the way we are going to do this is by storing the cabin ID and the guest ID right here in a booking. So let's do that. So cabin ID, and now comes the most important part. So to connect these two, we click here, which actually shows us that this is to edit the foreign key relation. And so here is where we do that. So let's then select a table to reference, which is going to be the cabin. And the column in there that we want to connect this with is exactly this ID. So this is exactly what we had in the diagram 2 lectures ago. And this is all we need to do. So now this table is connected with the ID, or with the cabin ID. And now let's do the same thing for a guest. So the guest ID will be a foreign key for the guests table, and in particular the ID column. All right. And so now let's then also create a brand new row in this table to see how the connection between these tables actually looks like in practice. So let's add the start date, and here we can just click on this calendar. So let's say I want to arrive next Monday, and I want to leave then on the Friday. Yeah, so that's going to be just 4 nights. So we can write that here with 2 guests, and the price here will be 300, let's say. Then let's say I also want breakfast, so that's going to be 60, at least if the price of breakfast is 15, as we were saying. And actually that should be 120, because we are 2 guests. Then the total price makes it 420, and the status is unconfirmed. So I didn't arrive yet at the booking. So I do have breakfast, I already paid, let's say, and I will arrive at 10 p.m. So a bit late. So it's nice to let them know about this. And now here we can then actually select the cabin. So let's click here, which will move to the cabin table. And so here I can now select this one because it's the only one that exists. So I'm going to be in cabin number 1. And now I also need to select my own guest information, which again is this one with the ID of 1. And so then that's the reason why the 1 appears there. And so as I save this, then exactly like we were saying, these important IDs are then saved here. And we can also see that this is a foreign key relation. Now, this course is by no means a database or an SQL course, but just as a side note, if in the future you want to model these kind of relations on your own, you need to think of these relations in terms of the number of entities that can be involved. So that sounds a bit difficult, but let me give you an example. So here with the bookings and the cabins, each booking can only have exactly one cabin, right? So one booking can only be about one cabin, not 2, not 3, but really only 1. On the other hand, one cabin can be involved in many, many different bookings. So over time, a cabin might be booked, for example, 100 times. But each booking can really only be for one exact cabin. And so that's what I meant initially when I said that we need to take into account the number of entities, basically, that are involved. And so this is important because we need to place the foreign key in the table that can only reference exactly one other row from another table. And so that's why the cabin ID and the guest ID are right here. So because again, each booking can only be about one exact cabin and one exact guest. All right. But anyway, with this, we finished building our tables here. And so let's just quickly move on. So now let's attempt to access our data from Supabase on our local computer. And then we're going to learn about row level security. So back here in Supabase, let's now come to this API docs. So basically, Supabase automatically creates an entire API documentation for all of our tables. So that's really helpful. And so let's check it out here for the cabins. So essentially, we can access our data using the JavaScript library. So by using this, and then all we have to do is to copy this code, or we can use it as an actual RESTful API. So that's what this here is. So we can basically just send a request to this URL right here, where this first part here is the URL of our project. And then we have here our table and then all the columns that we want. Then we need to send our API key and then here again, that key as an authorization header. So let's actually try to do that here. And so for each of the table columns, we have a different example here that we can copy. But let's come to the one where we read all the rows. So then let's come here where it says that the project API key is hidden. And so then here we need to select that we actually want to show our public, so this anon key right here. And so then basically this here is the key that we can use on the front end to access our data. But more about that later. For now, let's just copy this code and paste it into some terminal, because this is going to be a curl request. So curl is basically to make some HTTP requests right in the terminal. So let's paste that in, then let's hit enter, and we don't get an error, which is already a success. Now, we also don't get any data. So instead, we only get this empty array here. And so the reason for that is the row level security that we enabled at the very beginning when we first created this table. So what these row level security tables do is to prevent anyone who owns this key here from basically doing whatever they want with our database. So if it wasn't for the row level security or RLS policies, then whoever had this key here could really, for example, delete our database or edit whatever they wanted. So of course, we don't want that to happen. We only want certain operations to be allowed. And so that's why we can that's what we can set these RLS policies for. So row level security policies. So let me show you how we can do that. So let's come here to authentication. Yeah. And then here it is policies. So let's click on policies. And then here we have our 4 tables. And by the way, if you're wondering why we didn't create that users table for authentication, it's because we will do that separately. So the Supabase authentication feature doesn't require us to manually create a table, but instead Supabase will do that automatically. Our users are then going to be saved here in this table. But for now, let's stay here on these row level security policies. So we were working with the cabins table, and here again we can see that this row level security is actually enabled. And so that is again the reason why we didn't receive the data when we did that request. So in order to now allow us to actually receive the data, let's create a new policy. And so then let's select Get Started Quickly, because we just want to create the policy from a template. And so actually this first one is exactly what we want for now. So first we want to enable everyone to have read access to this table, while later we will probably then enable this one here. So only for authenticated users. But now let's do this one, use this template, and then we really just have to click here on Review and Save. Okay, and so what this one will do, as the name says, is to enable read access for everyone. And so if we come back to our terminal and then try that again, then beautiful. We have now our array with this very first object that we created. So this first cabin. Great. And if we wanted to create a post request, so to create a new cabin, then that again would not be allowed because we didn't create a new policy for that type of access yet. And we actually won't do that for now. So for now, let's just enable access to all of these resources for all users. And later on, we will then again change this so that only logged in users, so only authenticated users can do this. So can access all resources. Okay. And then also for the settings. So this code here is not really important. What matters is that now we will be able to access all this data right in our React application. And so let's actually do that in the next video. So now the time has finally come where we can connect our Supabase data with our React application. And actually, this is all going to be really, really easy, because if we come back here to the API documentation page, then right here in this introduction, they give us all the instructions that we need in order to do this connection. So remember how I said earlier that we can either use this API, so this RESTful URL, so basically this URL to connect to the RESTful API, or we can use the client JavaScript library. So that's what we're going to do now. So here they give us all the instructions for doing so. And so let's start by copying here this npm install string. And so with this, we just install the Supabase JavaScript library on our project. And then let's also immediately in our services create a new file. So this is basically a Supabase client where we will initialize the Supabase API and create a client so that we can then start querying our database. And so all the code that we need there is actually right here. So let's copy that and paste it right here. So here we have our Supabase URL. Then here we will need to place our Supabase key. And finally, we create a Supabase client based on these two informations. And then we can export that from here. So let's say export default Supabase. And then in some other file, we can import this Supabase client and start querying. All right. And so now let's actually grab our Supabase key from here and place it into that file. So that's here in the project settings and under API. So here we have our URL again, and then here that anon key. And so as I said in the last lecture also, this key is safe to use in a browser if we enabled row level security. So let's copy this and let's replace it right here. So again, you might be wondering that if we are exposing our Supabase key on the client, that then some malicious user might be able to hack our database. And the answer would actually be true if we didn't activate row level security. But since we did, anyone who has this key can only do whatever we allowed in the row level security policies. And so right now, remember that the only thing that we allow is to read data from our 4 tables. And so that's the reason why it is completely safe to expose this key here to the client. So even if anyone steals this, they can't do anything with it unless we allow it in a row level security policy. All right, so that is hopefully settled. And so let's now create a new file here for a service called API cabins. So for each of our tables, we will create one service here, basically. And so this is similar to what we did earlier in the previous project. So here we're going to have a bunch of functions, and the first one will be a function to get cabins. So just like this, and we will probably want to export this one here, and this will be an async function as well. And so let's return to our API page, and then let's go to cabins. And then what we want to do is to select all the columns. So basically read all the rows. And so we can actually just copy this snippet here, place that here. And so let's see what we have. So here we are using the Supabase client, which now we need to import here, which is exactly this one that we just created earlier. And so, as I was saying earlier, we will now basically query this Supabase client. So creating queries that will then return, in this case, from the cabin, all of the fields. So that's what this here means. So let's adapt this here a little bit. Here, there's no need to rename this. Let's just call it data. And let's also check if there is an error. So if so, then let's log something to the console, maybe even do an console.error. So cabins could not be loaded. And then throw a new error. And actually here, let's use this string. And here we will just want to log that error. All right, but if everything is well, then we will just return that data. Okay, so let's just recap. So from the Supabase client, we can now create queries with the from method. And so then we specify the name of the table, and then the fields that we want. And so here we want basically all of them. And so this returns a promise, which we then await, and the result of that gives us the data and a possible error. So if there is no error, then we simply return that data. And so now we are ready to use this service anywhere in our application. And let's do so just as an experiment here in the cabins page. So even though we said earlier that we were not going to do side effects inside pages, let's just do this as an experiment. So as soon as this page loads, let's basically fetch that data. So we're using an effect here just to run at the very beginning. So what we want is get cabins, which will then be imported from our services that we just created. And since this is an async function, we need to then handle that. And here let's just use a then. And then all we want to do here is to log that data to the console. So again, just an experiment, but this should already be working. So let's see. So from now on, we will not really need this anymore. So let's check. Let's just reload and then coming to the cabins. And beautiful. So that should be our data there. And indeed it is. This is exactly the cabin that we created a few videos ago. So congratulations, you just created yourself a backend and you have successfully connected it with your front-end application, which in this case is our React application. Great. So this is actually really empowering because this allows you now to really create full stack applications simply by leveraging a service like Supabase. So really, really cool stuff. And I'm really happy about this service and about how easy it is to build full stack applications with it. And now to wrap up this Supabase crash course, let's quickly set up 2 storage buckets where we can upload large files to. So back in Supabase, let's select the storage from the menu, and then here we can very easily create a new storage bucket. So let's create one for avatars. So basically for the avatar of our application users. And then let's make this a public bucket so that anyone can actually read the URL of all the files that are in the bucket. So that's actually not really a problem because row-level security policies are still going to be required for operations such as uploading or deleting files. So we can just save it like this, give it some time, and then let's also create another one for our cabin images. And again, let's make it public so that we can actually display the images from here on our web page. So let's save that. And then once the bucket is created, we can very easily upload files here just by drag and dropping. And so we already have our files actually. So on our desktop here in the source and then data and then cabins, here we have our images. So let's grab them and drag and drop them right here. And so now they are going to be uploaded here. So that's going to take some time. So I will be back here once this has been finished. So here we have now one image of each of the cabins. And so let's try this one. So we can click here, then we can see the file. We can see when it has been added. We can see the size and we can see the image itself. What we can also do is when we right click here or also here, get the URL. So let's try that. And then here in our cabin page, let's just quickly create an image with that source. Give it a save, and well, there it is. So we just easily updated an image here to our Supabase and are now able to render it here on our page. Nice. And by the way, I created these cabin images here using Midjourney some time ago. So that was still using version 4, but now that version 5 is already out and getting better every day, this already looks like old news here. But still, these images are very nice and very pretty, and so they are more than enough here for our application. Now, finally, what I'm gonna do is, since we already have this URL, I will go here to the table editor, and then in the cabins, I will add that URL. So we can just double click here and then save it. And so now if we load our data into the application again, we should be able to see that URL right there. So indeed, there it is. Great. And of course, in one of the lectures a bit later, we will also learn how to programmatically upload images to one of our buckets. Awesome. So with this, we finished the Supabase crash course. So we have our data inside our application now. So we just loaded it like this, but now we actually want to also kind of manage the state in our application. And so that's where React Query that we have been talking about so much will finally come into play. And so I'm really excited to finally show you my favorite React third-party library in the next section.